Hi, all my YouTube viewers. It's Crystal here. I'm just here to do another code review. This code review is going to be a continuation of the previous code review that I did. In an earlier code review, I did a Kaggle Playground series, and I used the extra trees. And one thing that I found doing the extra trees was that you have something called feature importance on extra trees and random forest. So I tried it on random forest, but I did not get as good level of accuracy on random forest than I did extra trees. So I decided to stick with extra trees. But what we're going to do in this video is we're going to show you how to use the feature importances, and then how you can drop the features that are not as important and see how that affects your accuracy. So that will be good to come in handy if you've got a data set with lots and lots and lots of columns of data and you want to remove some of those columns. Then if you use the feature importances, that'll tell you which columns are not so important, and you can drop those if you like. So when I ran this up on the Kaggle, I got an accuracy of 82.523%, which isn't too bad. It wasn't the highest level, but it's definitely not the worst. So we're going to talk about the problem statement for this Kaggle competition. And so the problem statement is you're going to determine if a student graduates. And then what we're going to do is we're going to import our libraries into the Jupyter Notebook. So we're going to import NumPy, which is going to it's going to create NumPy arrays and perform numerical computations. We're going to import pandas, which creates data frames and processes data. We're going to import OS, which goes into the operating system. We're going to import SciPy, which allows you to perform scientific computations. And we're going to import sklearn, which provides machine learning functionality. We're going to import matplotlib, which visualizes the data, and then sklearn, which statistically visualizes the data. So after we have imported our libraries, what we're going to do is we're going to use OS to actually download the data sets that we're going to be using. The data sets we're going to be using are going to be train, test, and sample submission. And then we're going to use pandas to actually read the data sets and convert them to data frames, and the data frames are going to be train, test, and submission. Then what we're going to do is we're going to use pandas to set it up to display all of the columns, because we've got a lot of columns in this data set, and if you don't display all of the columns, you're not going to know what all of the columns are. So we're going to look at the trained data set, and this is your trained data set. And at the very last column, you're going to have your target, and your target is going to be what we're going to be using to make predictions. So we check info. You can see all of the columns of data are numeric except for the last one, which is the target. Then we're going to check the test data frame, which is the same format as the trained data frame, except it does not have a final column of data that has the target, because we're going to be making those predictions. We're going to check submission, and that is what Kaggle wants to see when we submit our work. So we're going to drop the ID. The reason why we're going to drop the ID is because Pandas automatically indexes every row of data, so you don't need that. We're going to analyze the target. So the target equals train.pop target, and so it's going to pop the target out of the data frame, and then we're going to do a value counts, so you can see how many rows of data that you have for graduate, dropout, and enrolled. And then what we're going to do is we're going to create a histogram. And so you can see we have more graduates, a middle is dropout, and the least amount is enrolled. So now what we're going to do is we're going to use sklearn's label encoder to encode the target. And what it's going to do, it's going to convert the categorical values to numeric. And then we're going to analyze the train. So what we're going to do is we're going to create a heat map. And this is your heat map of the train data frame. And you can see that a few of the columns of data are highly correlated, but most of them are not that highly correlated. And then what we're going to do is we're going to check to see if any of the columns of data are not from the same distribution in the train and the test data frames. So the curricular units, 1 semester, approved, and grade are not from the same distribution. And I decided not to drop them. Under normal circumstances, I may very well have dropped them, but I decided in this instance not to drop them. And the reason why is because when you drop features, you have a tendency to lose accuracy. So I decided not to drop the features in this instance. Now we check the shape of our train and our test files, so you can see that. And now what we're going to do is we're going to define our dependent and our independent variables. Your dependent variable y is your target, your independent variable x is train, and x test is test. And so now we're going to define the model, which is going to be extra trees classifier. And I chose extra trees classifier because it had 100% when it trained the training set, but whenever I used random forest, it didn't have as high an accuracy. So I wanted it to be as high an accuracy as possible. So now what we're going to do is we're going to check the feature. So feature list is a blank array for name, importance, in zip, x dot columns, comma, model dot feature importances. Features equals name, comma, importance. Feature list dot append features. And then we're going to print the feature list with every element separated with a new line. So you can see that. And now what we want to do is we want to sort the feature list. Feature list dot sort, and it says key equals lambda x, x brackets 1, and then we're going to print the feature list as well. And then so the top one is the least importance, and the bottom one is the highest importance. So now what we're going to do is we're going to drop the least important features. So to drop, it says for name, importance, and feature list. If importance is less than 0.001, features equals name, comma, importance, to drop dot append features. And then features 0. And then the thing is we only had two columns of data that were not that which were less than 0.001, which was nationality and international. So if you wanted more, like let's say hypothetically you wanted more, you could say less than 0.01, and that would have dropped more features. So you can experiment with that and see what happens when you drop more features. And then after we have dropped features, we split the data set into training and validation sets using sklearn's train test split. And then we set up our extra trees classifier a second time. And you can see that when we train the training set, we have 100% accuracy, which is what we want to see. So now we're going to plot the feature importances on a horizontal bar plot, and you can see what the feature importances on the horizontal bar plot are. So now we're going to predict on the validation set, and we have 82% when we predict on the validation set, which is about 18 points lower than when we predicted on the train set. We have a data frame that we have developed so you can compare the actual values to the predicted values. Now we're going to predict on our test set, so you can see that this is the prediction, and then what we're going to do is we're going to use sklearn to inverse transform the label encoder. So now instead of numbers, it's going to be a categorical value, which is what Kaggle wants to see. And now we're going to prepare our submission. And when we prepare our submission, this is what the submission is going to look like, and we're going to submit our work to Kaggle. And when we have submitted our work to Kaggle, we got 82.523%. So that's basically how you want to use feature importances, and I just made it up. I just thought about, well, how's the best way to do this? And so that was the way that I figured it would be the best way to do it. Now, if you wanted to experiment with different models, you could have the extra tree model as the first one and the random forest model as the second one. So you can experiment with different models, you can experiment with different feature importances and see how high you can get your accuracy. But I just set it up to show you how to do it, and I made it up. I didn't look at any videos to find out how to do it or read any works to find out how to do it. I just thought about it, and I thought, well, this is how I would do it, so that's how I'm doing it. So I'm going to go ahead and close this video. Thank you so much for watching it. I will give you a link to the Jupyter Notebook so you can experiment if you want, and thank you so much for watching my video. If you like it, please like and subscribe, and I look forward to communicating with you in the next video.